Okay, so for this video, we're going to talk about section 3.5. It's in its entirety. There's only two objectives here, so hopefully it won't take that long. And our two objectives are going to be to compute the 5-number summary and to draw and interpret box plots. And again, if you've heard of something called box and whisker plots before, box and whisker plots and box plots are the exact same thing. They just updated the word and for some reason got rid of the whiskers. It's still the same exact thing. So the first thing that we're going to do is compute something called the 5-number summary. And eventually you're going to need those 5 numbers to draw a box plot, so very interrelated. Okay, so a 5-number summary of a set of data consists of the smallest data value, Q1, the median, Q3, and the largest data value. And you always organize it as follows. Your smallest number, your minimum, is going to go on the left, then Q1, then your median, then Q3, and then your maximum. And just keep in mind from when we started talking about Q1 and Q3 in a previous section, to find quartile 1 and quartile 3, you have to first find the median. Once you find the median, then you can go ahead and find your Q1 and your Q3. Okay, so every 6 months, the United States Federal Reserve Board conducts a survey of credit card plans in the United States. The following data are the interest rates charged by 10 credit card issuers randomly selected for the July 2005 survey. Determine the 5-number summary of the data. Okay, so here we have all of our banks, and again, the interest rates are on the right. So again, when I go to do this, again, I just pulled off the rates there. The first thing that I'm going to need to do is to write those numbers from the smallest to the largest number before I can talk about anything else. And I think I have them listed in order on the next slide. There we go. Okay, so here is that data in ascending order. Okay, again, you should take a second, make sure that is, I'm not sure if I typed that out for you or you have to write it, but there it is. Okay, easiest thing to do is to pull off your minimum and your maximum first. And I know when I tap again, it's going to show up, but so I'm going to try to write over here. So your minimum value is 6.5. And again, I'm just getting that from over here. And your maximum value, the furthest number to the right-hand side, is 14.5. That's easy. Okay, and then we have to find the median. Again, you have to find the median first before you can find Q1 or Q3. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10 numbers here. Even number of numbers, that means we're going to have to take the average of the two middle numbers. Okay, 10 divided by 2 would be 5. So it's going to be a combination of the 5th and 6th score in this row. So 1, 2, 3, 4, 5, and 6. So 13.3 is my 5th number, and 13.9 is my 6th number. So the average of those two numbers is going to give me what my median is. Try to write over here, because again, I know when I tap, I have other stuff typed on this slide. So again, the average of those two numbers, you're going to do 13.3 plus 13.9 and divide that by 2. Okay, when you do that, you should get an answer of 13.6. So 13.6 is going to be your median. And again, that's happening somewhere between 13.3 and 13.9. Not really somewhere. It's happening exactly halfway between. Okay, now to find Q1. Q1 is the median of your lower half of your data. Again, that 13.3 is not the median. So when I go to look at my lower half of the data, I'm including that 13.3 in the lower half of my data. And now when I count to the left of that squiggly line, there are 1, 2, 3, 4, 5 numbers. So if there's 5 numbers, that means there's going to be one true middle number. And in this case, that's going to be the number 12. Again, 5 plus 1 would give you 6, and then the halfway point of 6 would be 3. So it's the third number in that line. So that 12.0 is going to be Q1. Okay, and then I want to do that same thing over on that right-hand side. There's 1, 2, 3, 4, 5. So once again, the third number, 1, 2, 3, that number is going to end up being Q3. Okay, and again, it's going to be typed out a little bit neater when I click this next button here. Okay, so again, my smallest number is 6.5. My largest number is 14.5. Always get that out of the way first. Okay, and again, I wrote it as the first quartile is 12, but remember the first thing that we found was the second quartile. You have to find the second quartile first. And we found that over here. That's the median. Okay, that's 13.6. Then we went and found our Q1, which was over here for 12. And then our third quartile, again, we found over here, and that was 14.4. Okay, so our 5-number summary, again, from the smallest number to the largest number, 6.5, 12, 13.6, 14.4, and 14.5. So again, just make sure you write them in order from smallest to largest. Okay, so now what we're going to do is we're going to take that information, we're going to take those 5 numbers, and we're going to draw and interpret box plots. So there's only one new thing about a box plot that you need to know. What we want to talk about, we're always interested in statistics. From now until June, we're going to talk about having outliers, because outliers always affect your data. And sometimes we don't want to include those outliers in the data because we don't want it to skew our data. Okay, so drawing a box plot, we're going to talk about something called fences. Okay, if you have something that goes beyond the fences, it's going to be considered an outlier. So fences is going to be something new. So we're going to have to determine a lower fence and an upper fence. Okay, the lower fence is going to be Q1 minus 1.5 times the IQR. Again, the IQR, the interquartile range, is going to be Q3 minus Q1. That'll pop up in 1 second. Your upper fence is going to be Q3, your highest quartile, plus 1.5 times the IQR, the interquartile range. Again, where your IQR is Q3 minus Q1. Okay, now, you don't always have to include fences in a box plot. That's probably why you were never taught them in algebra. Algebra, you're not really concerned about outliers. In statistics, we're concerned about outliers. So if you don't have any outliers in your data, you really don't need to include your fences. We're going to include them in our box plot that we're about to do. Okay. So after we get those fences, and again, we'll get those fences on the next slide, we're going to draw a number line long enough to include the maximum and minimum values. And then we're going to put vertical lines at Q1, your median, and Q3. And we're going to enclose those lines in a box. And then we're going to label our upper and lower fences. And then we are going to draw a line from Q1 to the smallest data value that is larger than the lower fence, and from Q3 to the largest data value, again, that's smaller than the upper fence. That might not make sense yet because, again, you have never seen the fences, but when we draw the box plot, you will see what's going to happen with that. So step 4 might be a little confusing, but again, once we actually do the box plot, hopefully it'll get cleared up there. Okay, and any data value that's less than the lower fence or greater than the upper fence, again, those are our outliers, and we're going to end up marking them with an asterisk, a star over it. Okay, and again, that's probably going to be the only thing that's going to be new for you. Okay, so again, we're going to actually draw that plot. So the first thing that I did was draw a number line. So I just want to say something about this number line before I go up to figure out what my fences are. Okay, notice my number line starts at 6 and goes to 18. Again, my lowest value is 6.5. My highest value is 14.5. So it has to be inclusive of those numbers. So notice I started a little bit before the lower number and I ended up going higher than the 14.5. And I counted by ones, and I left rooms for the 0.5s in there too. So I have 6, 6.5, even though it's not labeled, 7, 7.5, so on and so forth. But let's just talk about the numbers that are printed. I went 6, 7, 8, 9, 10, all the way up to 18. So I counted by 1. Okay, you can't just start counting by a mishmash of numbers. In other words, I count 6, 7, 8, 9, 10. Totally legit. Maybe if you have a larger set of data, you might want to count by 2s. 2, 4, 6, 8, 10. Maybe you want to even have an even larger data values and you want to count by 5s. So you could say 5, 10, 15, 20, 25, 30. Right? But what you can't do is you can't just start counting by 5s and say 5, 10, 15, 20 And then when you get to 20, start counting by threes. So you can't go 5, 10, 15, 20, 23, 26, 29. Okay, once you count by a number, your entire line has to go by that number. Remember, it is a number line. It is not just random numbers that are thrown on that bottom line. Okay, so first let's find our IQR, because again, we're going to need that IQR, the interquartile range, to determine what our lower fences and our upper fences are. So our IQR is Q3 minus Q1. So again, Q3 is that 14.4 from right here. And then our Q1, first quartile, was 12.0 from right there. And when you subtract them, you're going to get 2.4. 2.4%. So that is your IQR. 2.4 is your IQR. So now let's calculate our fences. So our lower fence is going to be Q1 minus 1.5 times the IQR. Again, look back up at the top. The first quartile is 12, so that's why I put the 12 in there. Again, just brought over the minus sign. 1.5 is part of the formula, and we just found that 2.4. Make sure you follow order of operations. Multiply before you subtract. You can enter it into the calculator all at once as well. And your lower fence is going to be 8.4. For our upper fence, we need Q3. Okay, and again, Q3 is our 14.4. That's the last number over here. Okay, so that's why I brought that down there. This time we're adding. And again, I still need my 1.5. And that 2.4, again, the interquartile range is going in there. So when you do Q3 plus 1.5 times the IQR, again, you're going to get 18%. So 18 is your upper fence and 8.4 is your lower fence. Okay, so now I'm going to actually go on to my drawing the box and whisker plot here. So the first thing that I like to do is I like to do my fences first. And at my lower fence and my upper fence, I'm going to put brackets by those numbers. Okay, so in other words, 8.4 is my lower fence. That is going to be approximately right there. So I'm going to put my bracket there. And then I'm going to enclose it on the other side with my upper fence, which was 18. And that one is there. So that takes care of my fences. But why did I draw those fences? I drew those fences to see if I have an outlier. So on the top side, do I have any data value that was greater than 18? Nope. Again, your largest number was 14.5, so there's nothing that lies above the 18, so there's no outlier that's above your upper fence. But for your lower fence is 8.4. Hey, if you look back at your list of numbers, you have one number that is lower than 8.4 in that list. It's that 6.5. So that's an outlier. So 6.5 is an outlier. So above 6.5 on that box and whisker plot that we're drawing, we're going to draw an asterisk above 6.5. Okay, so that asterisk is my outlier. Okay, now, normally, again, lowest value, largest value gets dots over them. Let's do the dot for the largest number. 14.5, I'm going to put a dot above it. Okay, but because I have an outlier on the lower side of my data, I am not putting a dot. This already has an asterisk. The 6.5 already has an asterisk. So I need to find the first number that lies inside my fence here. So in other words, what's the next lowest data value after 6.5 in the data that we were just looking at? And it was 9.9. So 9.9 is inside that fence. So I am going to put a dot at 9.9. So even though 9.9 isn't that true lowest minimum number, it's the lowest number that's inside the fence. So that's what's getting your dot. Okay, and then I'm going to put vertical bars over my Q1, Q3, and my median. So your first quartile was 12. So there's my line over 12. My third quartile is 13.6. And that was my second quartile. And my third quartile is 14.4. Okay, and again, we're going to just enclose those vertical lines with a box, hence the name the box plot. And then we're taking the highest data value again, that dot that's on the right and connecting it to your box. And we're taking the lowest data value inside the fence. So this dot at 9.9, and we're connecting that. And there is your box plot. Again, the only thing that's new here is the fences and the outlier. And again, if you don't have an outlier, the fences aren't necessary. That's why you've never done them before. Wow, look how close to perfect that is. That's pretty good for me. Okay. So just like we looked at histograms and we talked about the shape of the data and described how they were skewed, you can do the same thing with box plots. So what I did was I took 3 different sets of data. Who knows what they represent, but just know that if you make a histogram of that data that I just put an asterisk above, it's going to look like this. Okay, and if you remember from earlier, that means because you have the tail on the right, that data is skewed to the right. Okay, whatever this raw data was, okay, I'm going to take that raw data from my histogram and now I'm going to make a box plot out of it. And this is the box plot that you'd get. Okay, just trust me on that. It is. Okay, and notice that your whisker is longer to the right than to the left. Your longer whisker on the right, that's skewed to the right. Notice in my middle one, again, that was the one that was symmetric. You don't have a longer tail on the right or the left there. And again, if I take that exact same data and make a box plot out of it, this is exactly what it would look like. And notice that on the left and the right, both your whiskers are the same exact size. That's symmetric. And again, for my last one, the tail for the histogram would be to the left there. And again, trust me, if you take this exact data from the top and you make a box plot out of it, it's going to become that bottom box plot. And again, notice the left whisker is longer than the right whisker. Again, the left whisker is longer. That means that that data is going to be skewed left. Okay. For the next one that we are going to do, by the way, this is on the left here, this is the interest rates that we just did with the banks that we were just talking about that we did by hand. Okay. So now this example is an example that we did in section 3.4 when we were talking about finding quartiles to begin with. So a group of Brigham Young University, Idaho students collected data in November of 2005 on the speed of vehicles traveling through a construction zone on a state highway where the posted speed was 25 miles per hour. The recorded speed of 14 randomly selected vehicles is given below. So we have the 14 speeds there, and we want to find the 5-number summary for the observed speeds, and then we want to construct a box plot for those observed speeds. Now, again, in the last section, we found the median, the first quartile, and the third quartile by hand. So now I want to go back into the calculator and again, just reiterate how to find all that information inside the calculator. Okay, so when you go into your calculator, you're going to we want to edit our list. So the first thing that we have to do is hit stat and then option number 1 to edit. And again, I pre-entered the 15 numbers so you wouldn't have to sit here and watch me enter them. Again, take a quick glance, make sure that you have try to make sure that you didn't make any typos in there. It's very easy to make a typo. Once you make a typo, it's going to change all your data. Okay. Once that data is in there, again, once you enter your 14th number, that 40, make sure that you hit enter so it actually takes that 40 into the calculator. That's my dog in the background. I don't know if you can hear him. I don't know what he's doing. So now we want the calculator to calculate something. So we're going to go back into stat and then over to calculate. And again, we want our 1 variable statistics, which is going to be option number 1. So just hit enter. Again, if you have the TI 84CE one, the color one, if you've done something using L2 in your last go around, it's going to still say L2. Okay, so just make sure if you have the newer calculator that it says 1 variable statistics and there's something about L1. If it doesn't say L1, just go hit the up arrow, whatever, clear it out, and L1 is above the number 1, so you'd hit second and the number 1. Okay, so just make sure it says L1. All the other calculators will automatically always go back to L1. Okay, and again, depending on which calculator you have, you're going to have to hit enter now. Depending again, if you have which version you have, you might have to hit it once, you might have to hit it 3 times. Okay, and now look over on the right-hand side of my screen. This gives you all the information that you need. That top number again, the X with the bar is our mean. I don't need the mean here. Okay, but as I scroll down, I can double check myself and the number of entries was 14. Okay, look at this. There's my minimum number. There's my Q1. There's my median, there's my third quartile, and there's my maximum. So the calculator is literally spitting out all the information that you need. So again, there's the information that you need. So I'm going to go back into the PowerPoint and hit my next slide. Again, there was my data, and I thought I had my things somewhere. I don't. Let me write them on here for you. I thought when I clicked next, it was going to come up. So from the calculator, again, your minimum value was a 20. Q1 was 28. Your median is 32.5. And again, if you go back to the last section, you'll see we got these same exact data values. Q3 is 38, and your maximum is 40. Okay, also let's talk about our bounds while we're on this slide, and I have some room. Okay, so our lower bound, LB for lower bound, again, that's going to be Q1 minus 1.5 times the IQR. Okay, so first, before I even do this, I know I need my IQR. Let me add that in over here. IQR, Q3 minus Q1. Q3 is 38, Q1 is 28, 38 minus 28 is 10. So our IQR is 10. So lower bound, Q1, 28 minus 1.5 times 10. And when you do that, you should get an answer of 13. So your lower bound is 13, and your upper bound, UB, is going to be Q3 plus 1.5 times your IQR. Again, Q3 is 38 plus 1.5, and again, that's going to be times 10. And when you do that, you should get an answer of 58. Okay, so there you have your lower bound and your upper bound. And if you just look up at that data and that list of numbers, you have no outliers then. You don't have any data value that's smaller than 13. You don't have any data value that's larger than 58. So when I go to draw my box plot, I do not need to include the fences because I do not have any outliers. Okay, so on the next slide, when we draw our box and whisker plot, our minimum and maximum are going to get dots. Q1, Q3, and the median are all getting vertical lines. Okay. So again, and I gave you the number line already, but if you count, notice again, we're counting by ones here. Okay, so again, my minimum value is 20. Minimum value gets a dot. And my maximum value is a 40. That gets a dot. Okay, Q1 was 28. So 25, 26, 27, 28. My median is 32.5. So somewhere between 32 and 33. And 38, 35, 36, 37, 38 is my third quartile. And again, I'm just going to enclose them. And then I am going to draw my whiskers in there. Okay, and again, they're asking me to determine the shape of that box plot. So again, is it going to be skewed left, skewed right, or is it symmetric? So again, you're looking at the whiskers and you want to know where the longer whisker lies. The longer whisker is to the left. So that means that this data is skewed left. So you can be given multiple box plots at one time and you can be asked to kind of compare what's going on here. So if you look at those 3 box plots on the left, it says which profession has the highest minimum income compared to the other 2. So if we're looking at the minimum income, again, we want the dot that's furthest to the left. So there's the minimum, and it wants to know which one has the highest minimum. So that one is the one that has the highest minimum. So that would be for a nuclear engineer. Whoops. Sorry. Oh, I've got to be careful where I touch over on this right-hand side of the screen. Engineer. Okay, and then it says which profession has the lowest maximum income compared to the other two. So this time we're looking at the spot that's furthest to the right, and we want to know which one of those X's is the lowest, so the furthest to the left, and that is the one that's over here with our police officer. So police officer. Okay, and then we want to talk about which profession has the greatest range of incomes. So again, range is, again, the highest data value minus the lowest data value. But you should be able to figure this out without even doing any of the math. Could you technically find exactly what the range is? Sure. But just look at the distance between the two dots for the highest and the lowest. You want the one that's the greatest range, or which would be the biggest difference, the one that has the furthest distance between the 2 points. That's with your musician down here. Those two red dots are your furthest apart. So musician. And which profession has the smallest interquartile range? So we want the smallest distance between Q1 and Q3. So we're looking from here to here, here to here, here to here. Could I get a rough idea as to what those were as actual numbers? I sure can. But again, I want the smallest distance between those two vertical lines. And that is going to be, in this case, with our police officers again. Okay, and for our last slide, we want to describe the shape of each box plot. So again, we're looking where our longer whiskers are. So if we look at our nuclear engineer, there's the left, there's the right. That's going to be skewed right. Left, right. The right is longer. That one's skewed right. Left, right. Again, that one's skewed right. So they are all skewed right. And which profession has more dispersion and why? Okay, more dispersion, again, is going to be how spread out the data is. And when you're looking for the one that has the most dispersion, again, you're looking for the one, when you're looking at box plots, you're looking for the one that has the biggest interquartile range. So again, that would be your one with your musicians. So your musicians. And again, the reason why is because it has the highest IQR. Oh, stop that. Oh, this thing hates me. Okay, you should have that answer from the top above. Sorry. So again, this one, let me not touch the right-hand side of my screen here. Musician, because it has the highest IQR. Okay, and again, these were all skewed right, just so you had it again. Okay, and you are done.